All right, so let us get started. So this is a 4-day webinar during which we are going to discuss a bit about data science. We will get started with an introduction to data science. Today, I will also be discussing what all applications we will look at in the next 4 days and also the methods that we are going to look at. So primarily, we are going to talk about 3 methods from the area of data science or from the area of machine learning. We will focus on support vector machines. We will talk about clustering, and we will talk about neural networks. The reason why I have chosen these 3 methods is support vector machines belongs primarily to the class of algorithms, which helps in supervised learning. Clustering belongs to the class of algorithm uh, that belongs to unsupervised learning, and the neural networks will get to see that what all things it can do. It also primarily belongs to the class of algorithm which helps us out in doing supervised learning. But then the question arises, what is this supervised learning? What is this unsupervised learning? What is this transfer learning? These are the very common terminologies that we get to hear whenever we are reading articles on data science, machine learning, artificial intelligence. So in today's session, primarily we are going to touch upon some of these topics, some of these terminologies, and develop an understanding so that we can at least have a conversation. We will also touch a bit upon Python. We will see that how Python works and what are the basic tools you need to install on your computer in order to be able to program in Python. So let us get started with an introduction to data science. So as we know that a lot of things around us are changing exponentially. So I very commonly do a session on exponential thinking for executive education participants who come down on the campus. Exponential thinking is important because there are at least a couple of things around us which are changing exponentially, which is computing speed, and the second thing is data creation. And in the current scenario, the COVID-19 scenario, there is a third thing as well, which is changing exponentially. So I'm sure most of you understand what does the exponential curve look like, right? So if you look at the exponential curve, we know that on an x and y axis, the curve grows like this very rapidly, isn't it? That is how the computing speed has been changing over the last 60 years. That is how data is getting created over the past few decades. So the question is, do we understand this exponential curve? What is the meaning of this exponential curve? If things are growing exponentially, where is it going to take us 10 years later, 20 years later, and so on? And the question arises, why is it important for businesses to understand this exponential curve? The thing is that we are not geared to think exponentially, we think linearly. Why do we think linearly? Because everything around us, if you talk about day, if you talk about night, how do the things around us change? Everything changes in a linear fashion. When we are walking linearly. Linearly in the sense, I know that I can walk 3 kilometers in an hour, right? So somebody says, hey, my house is 6 kilometers away. How long will you take to reach me if you're walking? I would say I will take 2 hours. Similarly, when I'm driving, again, I will extrapolate things in a linear manner, and I will be able to tell the person that in what time will I be able to reach to your place. So we are always thinking linearly. But then there is something which is changing exponentially, which is computation and data. Now, what does it mean for businesses? The problem is most of us do not understand what exponential curve is. For example, if I say each of the steps that I take is 1 meter long, where do I go in 30 steps? In 30 steps, I will go 30 meters. But if at all, I'm taking steps which are increasing exponentially, which means my first step is 1 meter long, my second step is 2 meters long, my third step is 4 meters long, then 8 meters long, 16 meters long, and so on. Where do I go in 30 steps? Now, this is a problem which people have discussed quite a bit in the past as well, ever since they started talking about exponential thinking. So in this case, 30 exponential steps where every next step is double of the previous step. And I'm starting with the first step, which is 1 meter long. Guess where will it take you? Does it take you to the moon? Does it take you to Mars? Is it 100 miles long? Is it 200 miles long? Very often when I interact with the participants and I ask this question, people start with, hey, this might be equal to the circumference of the Earth. Then somebody might say that, no, this is maybe equal to 100 miles, 200 miles. Then a third person tells that I can go to the moon in 30 exponential steps. And then I ask a question to the person, how far is the moon? And the person says, I don't know what is the distance to the moon. Well, 30 exponential steps are equal to a distance such that you can start from the Earth, go to the moon, come back to the Earth, and again go halfway to the moon. Now, if at all data and computing is changing exponentially, and your business is not geared to leverage some of these things around you, then what will happen? You are thinking that, all right, things are moving in a linear fashion. And then somebody, your competitor, grows exponentially. And what does it mean for your business? In a few years, your competitor is way ahead of you. And here, as you could see, there is this surprise factor. A lot of companies have seen these surprise factors. Nokia has seen it. Kodak has seen it. And I'm sure you are all aware of these very common examples. What displaced Kodak? What displaced Nokia? It's sheer innovation. It is sheer computation power. It is sheer their inability to understand this. Are you guys able to hear me?
Yes, sir.
Yeah.
Yes, sir.
Yeah.
Yes, sir.
Hold on. So there is some sort of a problem on the YouTube link. Okay, so the YouTube live link seems it's not working. A lot of people are complaining. I don't know how to fix it now. Just give me one moment, guys. Oh, now they're saying that they can hear me. All right, so there are few people who were not able to hear. I think there was some sort of a problem on their end. All the other participants are saying that they are able to hear me. So we'll go ahead. All right. So most of these companies have had this surprise factor. Again, when it comes to Kodak, people very commonly take an example of Steven Sesson. So Steven Sesson was a guy who actually developed the digital camera back in 1960s. And guess what was the resolution of the digital camera that he developed? It was 0.01 megapixel, right? But then over a period of time, if things are growing exponentially, what it means is that now we are already dealing in 20, 30, 40 megapixels. And a company that developed the first digital camera, right, got displaced in 2011. It filed for Chapter 11 bankruptcy in US. What displaced it? The digital camera, right? The integration of these camera on the phones was the reason that a big company like Kodak got displaced. Now, if at all I could emphasize a bit more on this growth, exponential growth of computational power, what you see in front of you is an ASCII red computer. It was commissioned back in 1997, and the cost at which this computer was commissioned was 55 million US dollars. And what was its speed? Its speed was 1.3 teraflops. So for people who do not understand what is the meaning of teraflops, it is like it can do 1.3 trillion computations in a second. So if I give you a problem, what is 2 plus 2? And you tell me that 2 plus 2 is equal to 4. You took 1 second to solve this problem. This computer could do 1.3 trillion such computations, right? And the cost of this machine, of course, back in 1997 was 55 million US dollars. And it was developed after there was a moratorium on nuclear testing. So US wanted to manage its nuclear arsenal, and it invested a huge sum of money towards the development of this computer. But then comes the year 2006. Look at this machine. The cost of this machine is 499 US dollars. The speed is almost twice that of ASCII read computer. So what has happened in 9 years? Kids are playing with a computer which is twice as fast as ASCII read. They are sitting in their living areas, in their living rooms, and playing with a computer twice as fast as ASCII read. What is the price of the machine? Just 500 US dollars. Now this violates Murphy's law. What kind of a violation are we talking about? We are talking about a violation where the machine is getting cheaper, the machine is getting faster, the machine is getting smaller. So all the objectives that you can think of are improving. What happens when you go to buy a house? If you go for a house which is bigger, then what happens? You have to pay more. If you go for a house which is in a more posh location, you have to pay more. Whereas in this case, what is happening? All the objectives are improving at the same time. Now, one of the participants is already writing it in front of me. It's nothing but the Moore's law, right? One of the participants just wrote it on the screen. That's the Moore's law, and many of us are already aware of it, that the computational speed is doubling every year, and it has been doubling since 1960s. If I could further emphasize, I very commonly ask a question to the students that, hey, if on a scale of 0 to 100, I have to rank my intelligence, how much would that be? Somebody would say that, hey, that would be around 90, 95, or 100. What will be the intelligence of this mobile phone? And the person says, well, sir, the intelligence of the mobile phone would be maybe 1 unit. Your intelligence would be 100 units. And then my question arises, how intelligent will my phone be in 1 year time? The guy says, it's 2 units. In 2 years, it is 4 units. So what does it mean? Where does this machine or this phone go in a few years' time? Let's see. So right now, this machine has got an intelligence of 1 unit. In 1 year, it becomes 2, then 4, then 8, then 16, then 32, then 64, and then 128. 1, 2, 3, 4, 5, 6, 7. So in 7 years, what this Moore's law suggests is that this phone will be smarter than me. And therefore, in the 7th year, I'll be carrying a human in my pocket. And in the 8th year, I will be carrying 2 humans in my pocket. And 9th year, 4 humans in my pocket. And as soon as I give this example, then the person says, hey, I think this level of 1 that I assigned to this machine was a bit too high. I should assign it a score of 0.01. Well, even then, if not in 8 years, in 20, 30, 40 years, it might reach the level of a human. Now, of course, there is a counter to it as well. Some people claim that no, as soon as we start approaching human level intelligence, it's going to get more and more difficult. And the point at which you will be able to achieve human level intelligence, a machine will be able to achieve human level intelligence, it's called a point of singularity. Can we achieve it? Can we not achieve it? Again, that's a debate that people are commonly having. And I'm sure even those things you must be reading around you in articles and books and stuff of this sort. Now, there is a management thinker, Stephen Kotler. He talks about 6 Ds of technology. Now, what he talks about is that whenever a technology gets digitized, now we have been living in very interesting times because during our lives, a lot of things have got digitized. Photographs have got digitized, books have got digitized, Britannica has got digitized. It's available in the form of Wikipedia now. Who refers to Britannica? I remember as kids, we used to go to the libraries. I had to write an article on Taj Mahal. I would pick up Britannica starting with the letter T and write an article on Taj Mahal for my project. But now my kid refers to Wikipedia. So a lot of things have got digitized during our lifetimes. Now, whenever a technology gets digitized, it grows through this phase of 6D. What do I mean by 6D? So whenever something gets digitized, the quality usually is very poor and people tend to disregard it, just like the photograph. Steven Sasson digitized the photographs, came up with a digital camera. What was the quality? 0.01. And of course, Kodak would have said, hey, who's going to use this digital camera? 0.01 megapixels. The camera used to weigh 4 kilograms. You have to sit in front of the camera for 20 seconds, and then it clicks your photograph. And then you plug that camera to a television to see your 0.01 megapixel photograph. And everybody was kind of discarding the technology at that time. But then 0.01 megapixels, 0.02 megapixels, 0.04 megapixels, and so on. And where are we right now? There has been a disruption, and Kodak has been completely displaced. And whichever company misses this deceptive phase, it will be surprised as soon as the technology disrupts your business and you are left behind and you are no more in the race. But then what follows disruption? What happens after disruption? Disruption is always followed by dematerialization. Everything that was available in the form of a material is available in a digital form, and therefore we call that dematerialization of the product. And as soon as something gets dematerialized, the price of that particular thing comes down sharply. A book that we used to buy for 300 rupees, HMV cassettes, which back in the 1990s we used to buy for 50 rupees. Now, will you pay for a song 10 rupees or 20 rupees for a song? I'm sure you will not. But I remember back in 1990s we used to collect money to buy an HMV cassette of A.R. Rahman songs. I don't do that anymore. 50 rupees for 6 songs is way too expensive right now, isn't it? So dematerialization of books, dematerialization of a lot of other things leads to a rapid reduction in price because there is no transportation cost, there is no distribution cost. Things can be distributed instantly. There is no storage cost, there is no warehousing cost. And as soon as dematerialization happens, the price of that item falls down sharply. And that is something we call as demonetization. It's not the same demonetization that our prime minister did. It's a different demonetization, that the article or the product becomes practically free. And that is what we see. And as soon as something becomes almost free, the technology or the product is available to everyone. And that is what we say is democratization of the technology or democratization of the product. Now you could see almost everyone clicking photograph in every nook and corner, clicking a selfie. Back in 1990s, was it a technology which was democratized, which was available to everyone? No. Every family, or maybe a few families, we had one camera with 36 snaps. And the entire family used to stand in the background with a smile, with their eyes wide open. Nobody blinks. Otherwise, your photograph comes with your eyes closed. Isn't it? Now everybody has a phone, everybody has a camera, and a complete democratization has happened. Now the question that arises is, if things get demonetized, if things get democratized, can you make money out of it? And that's what we often talk about in our entrepreneurship courses, that yes, you can still make money even if something gets demonetized, even if something gets democratized. Your business model has to completely change. You cannot sell cassettes. You have to come up with a business model like Spotify, where 10 million songs are available to a user for $10 a month. What is the price of each song? Practically zero. 10 million songs available to me on my fingertips. And therefore, along this curve, What has to change over a period of time when something is growing exponentially? Your business model has to change. And you can change, you can adapt only when you recognize that something is changing in an exponential manner. And if we are not thinking exponentially, if we don't understand this exponential curve, it will be very hard for us to stay in business. 5 years back, did I ever imagine that my kids will be talking to a machine? Well, they are talking to a machine right now. My 4-year-old daughter, she talks to Alexa, not just talks to Alexa, but complains that, hey, Papa, Alexa is stupid. It is not able to answer my questions properly. Right? So that's the world we are living in. And how much time has it taken? 5 years? 6 years back? I never thought of that. My kids will be talking to devices. A lot of people say that, all right, in US there are self-driving cars. Those cars are not going to work in India. Whenever I talk to somebody, what about self-driving cars coming to India? They say, no, no, Indian roads, so clumsy. It's so clumsy. It's so crowdy. I don't think self-driving cars are going to work in India, isn't it? But things growing exponentially around us, believe me, within 10 years, we will have things working over here as well. What exactly do we need? We need to train the cars on models within India. Right now, most of these training is happening in the developed country, in US and all. But I'm sure it's just a matter of collecting data. It's just a matter of having sufficient number of sensors and computing power. I don't see a problem why in the next decade or a bit more, the cars will start operating in India as well if things are actually growing exponentially around us. Right? So the key questions that I would like to put forward in front of you is, how digital is your industry? The industry in which you are working in, is it digital? How is data going to drive your future? Is your industry, is your company dependent on data? What is going to be the role of machine learning and artificial intelligence in your organization? Is it going to replace some of the jobs? Is it going to replace your jobs? You remember during the manufacturing phase, what happened? When automation entered manufacturing, a lot of people were thrown out of the jobs. And where did these laborers, these workers find jobs? They entered the service sector. And the question that we are grappling right now is that now these machine learning and artificial intelligence tools are replacing the jobs in services. This entire business, BPOs and all, where people used to interact with the customers, it's mostly bots. It's mostly machines interacting with the customers. That means all those jobs have disappeared. The other question that arises is, how are your competitors responding to this change? Are you aware of the innovations that are going around you? There are a lot of startups, small companies coming up. You have to keep your eyes open if you really want to stay in business. You have to keep an eye as to what these guys are doing. And whatever these guys are doing, is it relevant for your company? Is it relevant for your organization? Should you go and learn from there? And therefore, it's very important for most of the organizations to have some sort of an intrapreneurship unit within their companies, because you never know when a new piece of technology is going to come up and you are completely redundant. So the question that I finally pose to you is, how are you responding to this change? Now, of course, when we talk about data, when added to the computational power, creates a digital revolution. There is a lot of data, there is a lot of computational power. When the two things come together, a digital revolution is created. Now, what does this digital revolution lead to? What does it lead to? Any example? Let's take a very common example again. An example of Uber. What has Uber done over the past few years? Is Uber something that you consider innovative? Has it impacted our lives? I'm sure most of you would say, yes, sir, it has impacted our lives. it is innovation. But then along with that, it has led to a few more important things. It has driven the productivity up. How has it driven the productivity up? We call that such kind of business models like Uber, Airbnb belongs to the idea of sharing economy. What is this sharing economy? Before the advent of Uber, there is a driver, there is a person, and there is a car. Both of them are sitting idle. The guy has a car parked in his garage, and the person is sitting in the house, and the person is complaining, hey, I don't have a job. I don't have a job. What to do? And both the resources of the economy are lying idle. But with the advent of Uber, it allows such people to take their cars and start working right away. And therefore, it has increased the utilization of two resources of the economy. It increased the utilization of a car which was lying idle. It increased the utilization of a person who was lying idle. And how did it increase the utilization? By making a lot of people share the same resource, share the same car. So this is an innovative business model which has driven the productivity up. Has it transformed employment? Yes, it has transformed employment because people are getting into more of a gig employment kind of a thing. They work whenever they want, they switch off their mobile phones and go home whenever they don't feel like working. And that's altogether a new kind of an employment that these business models have given rise to. Are such kind of business models affecting economy? Yes, they are definitely affecting economy. It not only has impacted the automotive business, as somebody just mentioned on the chat as well, real estate companies have also been impacted by Uber. For example, in the city of New York, Manhattan used to have the most costly rental apartments, and the area of Brooklyn was much cheaper, right? Because it was very costly for people to travel from Brooklyn to Manhattan, maybe $50 one way, and therefore you very easily end up spending $100 in one day. And if you have 20 days working in a month, then if you're taking a taxi, you end up spending $2,000 a month. So it was more wise to pay an extra rent and stay in the Manhattan area than stay in the outskirts in the Brooklyn area. But then with the advent of Uber, what happened? The taxi prices came down, and therefore people thought that, okay, we can live even a bit far away. We can live in the Brooklyn area. And what did it impact? The rental prices in Brooklyn went up. And similarly, in many other cities, Uber led to the development, real estate development of places which are far away from the city as well. So definitely it has impacted the economy. Has it changed customer behavior? A lot of people who never used cars, who never used taxis, they are booking Uber and traveling. When did I book a taxi? When I had to go to the airport. If I had to go 2 miles away, I used to take an auto rickshaw. Am I taking an auto rickshaw now? No, because Uber is a lot easier and I just take a car. So it has changed my behavior. And at the same time, I assume it has changed the behavior of a lot of people around us. And if at all I talk about what is their business model based on, there's a lot of data analytics which is going on in the background of the app that you are using. Where should a driver park his car? Where should a driver be located so that he or she can reach the customer quickly and easily? They also do a lot of prediction. For example, let's say there is a shopping mall or there is a movie theater. They would know well in advance that at 9 o'clock in the evening, a movie is going to get over and suddenly the demand will rise. If they can do this prediction, they can already let the taxi drivers know that they should go and park their cars near the movie theater. All these things are not achievable if you are not doing data analytics properly, right? So most of the companies, most of the organizations that you look around yourself are very much dependent on data. Now, if you look at how has data been growing, here is the exponential pace. Now, see, in the past, if you just look at the right-hand side, there are a lot of things which are given: multimedia, manufacturing data, text data, structured data, and all these kind of things. In the past, we had the capability to analyze only structured data. What do I mean by structured data? By structured data, I mean a data set which has well-defined rows and columns. If some of you have used regression in the past, on what kind of a data set do you do regression? Your data set has some rows, has some columns. It is there in the form of a matrix. Each column is a variable, and you do the regression task. This is an example of structured data. And we were able to analyze only this kind of data. But now, with the advent of modern machine learning and artificial intelligence tools, we are able to analyze unstructured data as well. What is unstructured data? Unstructured data is like a bunch of photographs. Your bunch of photographs is unstructured data. A bunch of videos is unstructured data. A bunch of news articles, it is unstructured data. Now, with the current tools, we are able to analyze even such information, such data, and extract information out of such data sets. And as you could see in this chart, the unstructured data forms the major part of the data set that is available around us. The structured data set is very small, only this much, around 10% of the overall data that is getting generated around us. And now we have the capability to analyze not just structured data, but any kind of data. And the pace at which the companies are making the technologies available to us, even that is amazing. 5 years back, I remember, or 6 years back, there was a research paper in which they mentioned that the capability with which we can analyze images and figure out what all objects are present in the images, we are able to do that at a very good accuracy. I think it was a 2014 research article that I was reading around 6 years back. And we will be talking about that technology in this webinar, right? And I will be giving you the codes, the model, everything to you. And you will be able, all of you will be able to run this technology on your computer, right? So in 6 years time, what has happened? The technology is democratized. It is available to everyone. And within 5 minutes, you will be able to implement the technology on your computer. Now, let's say as a business, you're not available about such kind of technologies which exist around you. And you're not even aware that within 5 or 10 minutes, it can be integrated. As managers, things are going to be very difficult for you. Anybody could come and cheat you. A consultant will come, hey, I will develop a technology, an object recognition technology, where through your web camera, I can recognize people, I can recognize objects, and I will charge 1 crore from you. Well, you don't have to pay them. These things are available for free. All you need is a person, a manager who knows that such kind of technologies are available and it can be easily integrated with my existing systems, and I can offer a better product, a better offering to my customers. And then, of course, you might have heard of Internet of Things, right? Now, what kind of an impact is it going to have in our lives? We expect that in a couple of years, 20 billion devices will be on the internet. Every time you are going to walk, you're going to generate data, and that is going on the internet. With 20 billion devices sending data on the internet, and if you're not utilizing it, you're not doing anything with that data, then definitely you will be left behind in a race. I'm sure there will be a lot of people who will be thinking in a traditional manner. That why do we need to install sensors in the shoes? Who wants that? Why do we install sensors in tube lights, in bulbs, in fans? Well, the problem is in a few years, you will not have an option. It will come pre-installed on all the devices because things are available for almost free. These sensors, a very small sensor, which is there in front of you. The size of this sensor is 2 millimeters by 2 millimeters, and the cost of this sensor is 0.75. So your keychain will come pre-installed with this sensor, and you will not have an option to say that I don't want a keychain with a sensor. I remember when the smartphones came in, my parents always used to complain that, hey, this touch screen is very difficult for me to use. I don't think I can adapt or I can adopt this kind of a phone. I'm very happy with my traditional Nokia phone on which I can click. But then what is the current scenario? Those phones are no more available. There is no more option present to them. And anyway, they're spending all of their retired life sending WhatsApp messages on a touchscreen phone. They just don't have an option, right? And I'm sure they don't even want to return back to that old phone. Now, within your business unit, what all tools and techniques can you use to turn data into meaningful information? Across your value chain, right from the supply side until the end to the customer side, what all units will be impacted? Everything will get impacted. The way you write your contracts will be impacted. The way you select suppliers will be impacted. The way you run the process of your organization will be impacted. I was just looking at a WhatsApp message that what led to the digital transformation of your organization. You have three options. Did the CTO lead to the digital transformation? Did the CEO lead to the digital transformation? Or was it COVID-19? I think because of COVID-19, a lot of corporations, organizations are transforming digitally. The way you interact with your customers, everybody, if you just look at the recent Google searches that people are doing, of course, people are talking about Zoom. A lot of people are talking about Google Classrooms. So many of the schools which were not digital, they're looking at how can I go digital? How can you interact with the parents, with the kids online? Isn't it? So even on the customer side, you have to transform yourself digitally. Whatever data is generated by the customers, you have to take that and adapt the product so that you can provide a better delivery to your customers. All right, now let's talk about the kind of tools that are available to us. Now, most of us are aware of descriptive analytics. What is descriptive analytics? Descriptive analytics is more like mean, median, mode, and all those kind of things that we have been using in our schools and colleges. Now, what do we use mean, median, and mode for? A data set is given to me. I calculate the mean, median, mode, and then I look at, hey, the mean is shifting. The mean is becoming smaller. And based on this analysis, what do? I recognize a problem. I recognize a problem. I do diagnostic analytics based on the mean, median, modes, and stuff like that. And I try to correct the problem. Now, these are few things I do only when the data is available, only when something wrong has happened. I try to do a diagnosis and try to correct it, right? So descriptive analytics is followed by diagnostic analytics. But then the next thing which follows diagnostic analytics is predictive analytics. What is predictive and what kind of tools do we use in predictive analytics? We will have a look at that in a while, and then we will talk about prescriptive analytics as well. So predictive analytics is again related to prediction. Why do I face a problem and then go back and correct it? Can't I predict it? If I am able to predict things, then in that case, I capture the problem even before that happens. And if at all I'm able to predict things, why can't I adjust the parameters of my system in such a way so that my platform or my service delivers the most optimal output? And therefore, what am I doing? I'm generating a prescription that make your product, make your system, make your service work in this way, because this is the output it will lead to, which the customers will like the most. And that is like giving a prescription. So we are moving from descriptive analytics to prescriptive analytics. Now, what are the tools that we use for descriptive, predictive, and prescriptive analytics? So descriptive is more like distributions, mean, median, mode. When you're talking about prediction, Predictive analytics, it's like neural networks, support vector machines, and stuff like that. And in this particular webinar, we'll basically be focusing on the predictive parts, right? Even the next step is prescriptive. What do I mean by prescriptive? If I'm able to predict things, so along with prediction, if I can optimize it and tell the user of the system that do this to get the best result, then it is like giving a prescription. So when predictive analytics tools are combined with optimization, you get a prescription, right? We will not be talking about any optimization during the webinar. Rather, we will be mostly focusing on the predictive aspects. Now, applications of analytics is present across all the sectors that you can think of, right? These are some of the manufacturing companies generating a lot of data. You can let a blast furnace run without any intervention of a human being. Why do you want to avoid the intervention of a human being in a steel company? Because steel companies traditionally have been very dirty, very poisonous, right? So if at all you can remove the human beings and let the plant run automatically, what better? Of course, a lot of people will end up losing the jobs. On the other hand, if you look at uh, car companies, the level of automation in these companies is already quite high. Mobility, Uber, Ola, Lyft. So we've already taken an example of Uber. What about logistic companies, DHL, FedEx, UPS? Now, these are companies which have to optimize the work that they do, right? Similarly, if I talk about the retail companies and the e-commerce companies, if I again compare Walmart, Flipkart, Amazon, let's talk about Flipkart versus Amazon, right? What are these companies competing on and who is going to be the survivor? Well, it won't be wrong to say that Flipkart and Amazon are competing just based on cost because there is hardly any differentiation between the two companies. These businesses are more like monopolistic businesses. There is no space for 5 or 10 e-commerce companies to survive. It will be very hard. These are monopolistic businesses. And that's why we are aware of a lot of companies disappeared in the past. Snapdeal, right? What happened to Snapdeal, all of us? No. Flipkart also, I don't know how good a phase are they going through. So these are monopolistic businesses. There is little differentiation and they are competing just based on cost. Now, if at all they do not optimize their processes, if they do not try to reduce the cost, if they are not using data properly, then they are not going to survive. Because the person who operates on a smaller margin will get a bigger base of customer. And if you cannot lower down your margin, or if you lower down your margin significantly, get into big billion days sales and offer a lot of freebies to your customer, it might be hard for you to return back from the losses. Banking and finance industries. BFSI companies also generate a lot of data. Companies like Zerodha, insurance firms, Max Life Insurance. Now, what do you think? How much of data analytics some of these firms might be doing? It will be enormous. Now, these are just some of the applications that I have listed in front of you. Tools from the area of machine learning and artificial intelligence can be used for defect tracking, product quality. It can be used for forecasting, personalization, automation, and in general for improving efficiency. So we'll now come to the applications that we are going to talk about in sessions of this webinar. All the data that I'm going to discuss in this webinar will be provided through this particular link that is there in front of you. I've also shared this over the email. Let's look at one of the examples that we'll be talking about in tomorrow's session. So one of the examples that we will be discussing would be the loan acceptance data set. In the loan acceptance data set, you will have a lot of customers. Each row represents a customer, right? So what all things do I know about the customer? I know how many kids the customer has, what is the annual household salary of the customer, how much loan amount the person is requesting for, is the person a car owner or not a car owner, and what is the education level of the person. Now, this represents your past data. What do I mean by past data? This is the past data which tells me that based on these attributes for a person, whether a loan was granted to this person or the loan was not granted to this person. If the loan was granted or not granted, would there be a possibility for me to learn this pattern and automate this decision? Now, of course, you can use machine learning for this, and this process can be easily automated. You don't want a person to sit in front of the computer, look at this data, and then make a decision that whether to grant loan or not to grant loan. And as we know that whenever humans are making such kind of decisions, there could be a lot of biases. There could be a lot of preferences, unwanted preferences. The person might not give me a loan just because the person doesn't like my face. The person gives you a loan because the person likes your face, right? And therefore, maybe at times you want to automate such processes. And this is your past data available. Now, can you learn from this data and create a model? That is what we will do in tomorrow's session. Another data set that we will be talking about is a multi-commodity data. In this data set, what we'll be doing is there are 20 products which a company is selling, and the company knows that out of these 20 products, what all products a person has bought and what all products a person has not bought. And the company also knows that whether the person is a male or the person is a female. Now, next time, because of some regulatory issues, the company doesn't want the customers to answer this question that whether the person is a male or a female. Now, the question arises that based on my past data, can I automatically figure out based on the purchases of the person that whether the person is a male or female? Now, as you could see, these examples could be generalized to a lot of other applications as well. I've tried to keep these examples simple so that I can cater to this diverse audience that is coming from a variety of backgrounds. Some of you are students, some of you are executives, some of you are PhDs. That's what I got to see in your registration, where you provided me additional information. So intentionally, I have kept these data sets slightly simple so all of you can associate with the problem that we are going to consider. The third problem that we are going to talk about is clustering locations. Now, what is the application of clustering? In this case, what we will do is we have a set of locations, around 60 cities are there, and I want to form clusters. Cluster of cities. Why do I want to form clusters? Let's say I only have 5 vehicles, and these vehicles have to go and serve a good. If I could cluster the cities in 5 different clusters, then I can assign one vehicle to each cluster, and the vehicle can route within a cluster and serve all the customers. That is where this clustering problem comes up. This is not just the only place where you can use clustering. Many a times you want to cluster your customers. For example, let's say you have 1 million customers and your boss tells you that create 3 marketing plans for the customers. Now, how do you come up with 3 different marketing plans? First of all, you have to put your customers into 3 different baskets. Look at the attributes of the customers in each of the basket and then create a marketing plan for them. So how do you even achieve these 3 different baskets to begin with? That itself might be a difficult task, and that is where clustering will come to your rescue, that you segment your customers into 3 different baskets. And this segmentation happens based on similarity. A set of similar customers go in one basket, another set of similar customers go in the second basket, the third set of similar customers go to the third basket. All right? It could be customer segmentation, it could be product segmentation. There are a lot of plethora of examples where such kind of methods and techniques that can be used. We will also see that how tools such as handwriting recognition technologies can be used. So I will provide you the codes, I will provide you the data sets using which you will be able to do simple recognitions like recognizing a digit that a person has written, so that you are able to, you are aware as to how some of these technologies work. You don't have to kind of go back and start coding some of these things. It will be good to try it out once because I will be providing the codes, but at least you will develop an understanding that all these interesting technologies that I'm getting to see around me, where somebody is able to recognize my face, somebody is able to recognize my handwriting, how some of these technologies work. I'll also be sharing with you a model, which is an object detection model. This is something you will be able to use as well and apply it on any image of your liking. For example, in this case, if you input the image to the model is able to identify that there is a bicycle and a person in the image. And there could be hundreds of such objects within this image, and the model will be able to identify all of these things. All right, now let's try to understand some of these things. What is supervised learning and what is unsupervised learning? These are some terminologies which experts in the area of machine learning and artificial intelligence very often use. Now let's see. Let us see. Now there is a teacher and there is a student. If the teacher is giving an instruction to a small baby, to a small student, and explaining to the little guy that in the picture that you see, the big ones are dogs and the small ones are cat. Now, how is the baby able to recognize that what is a dog and what is a cat? The child is able to recognize some of these things based on the inputs that are coming from the teacher. The teacher specifically tells this is a dog, this is a cat. Now, based on this instruction, the kid is able to do this identification. However, what happens after that? This little baby sees a fox. What will the baby say? That, hey, look, that's a dog. Because the network in the brain of the kid has still not learned to identify foxes. The kid is not able to identify foxes. It only knows how to identify cats and dogs. And again, the teacher comes and provides an input to the baby that, hey, that is not a dog, that is a fox. Now here, the learning is happening based on instruction from the teacher. Somebody is training the child. Now you can think of the child as a model. When it comes to the first case, you have a row, a vector, and each vector is identified that this is a dog, this is a cat, and you train a model which is able to learn this. However, your model has never seen a fox. And therefore, whenever a fox is encountered, your model is going to classify this fox as a dog. Right? And therefore, what do you need to do? You need to train your model. And how does the training happen? The training again happens based on instructions. So new data means that a model update is required. Let's talk about unsupervised learning. Let's think of a guy who has always lived in the forest and has never encountered a teacher. Let's think of Mowgli. Now, will Mowgli be able to identify dogs and cats without any instruction? The answer is yes. Even Mowgli, without any instruction, will be able to learn that the big ones belong to one category and the small ones belong to the other category. He might not call it a dog, he might not call it a cat, but he would be able to differentiate between the two. And he will say that, okay, this is one category of species, and this one is another category of species. So the question that arises is, how is Mowgli learning? Mowgli is learning based on the similarity in the objects. However, if Mowgli looks at a small dog like this, a dog who has a flat face, now Mowgli would think that this is not a dog. Mowgli would classify this dog as a cat, because how has Mowgli learned to classify? Mowgli has learned to classify based on size and based on face. Now, based on size and based on face, Mowgli realizes that this particular animal is a cat. Now, what happens as soon as the animal speaks? Mowgli feels that this particular animal is speaking like the bigger species. And then he might add one more dimension to his data set, and he will say, I should not look at only two dimensions, which is size and face. I should look at the third dimension as well, which is sound. And as soon as I incorporate the third dimension, the model in Mowgli's mind gets updated, and he starts putting this particular small dog into the right category. Now, as you could see, there are two kinds of learnings happening over here. One is based on instructions from a person, and the second one is happening just based on similarity. There is no instruction that is coming in. Just based on similarity, a person is classifying or clustering things into different baskets. There's also something called transfer learning, which some of you guys might have encountered. What is transfer learning? If you look at transfer learning, let's say there's a sadhu living in Indian forests, and this particular guy is able to identify monkeys and wolves. Now, if this person is able to identify monkeys and wolves, that means there is a model already existing in the mind of this person. Let's go one step ahead. This sadhu goes to the African forests. Now, when this sadhu goes to the African forests, he sees these two animals. The first animal is a baboon, and the second animal is a hyena. Now, the question is, what will the sadhu say? Now, the sadhu already has a model existing in his mind. This particular guy knows that the first one is very similar to a monkey, and the second is very similar to a wolf. And he will also know that the first one will have similar characteristics as a monkey. The second one will have similar characteristics as a wolf. Particularly, the hyena might be dangerous as a wolf, and a baboon might not be as dangerous because it looks similar to a monkey. So when I take a model, when I take some learning which happened in Indian forests, and I try to apply that learning in African forests, it still works. And that is what we call as transfer learning. How can I improve this model? How can I improve this sadhu? A little bit of instruction. I will say, hey, these are different animals. The first one is called a baboon. Yes, it's very similar to a monkey. The second one is called a hyena. It has these black spots on his body, similar to a wolf. But yeah, these are small differences. And with this little update, with this little data, transfer learning starts working very well. I don't need a huge data set. I don't need huge information, just a little bit of input. Things that have been developed elsewhere start working in a different context, in a different area, in a different country. All right, so this was a bit of an introduction that I wanted to give to the area of data science. I think we've already completed 1 hour, and that was what the session was intended to be. But now, whosoever is interested in the Python aspects can stay with me. I will spend another 20 minutes or so on Python, and the people who already have a background in programming, who are already aware of how to work with Python programming language, please feel free to drop out.